One point that is typically pretty muddy for the first time that you're studying thermodynamics is this difference between reversible and irreversible processes. Let's explore this a bit. The main thing to remember is that if you can imagine simply reversing the process that you've done and arriving back at the initial state that you started in, that process is reversible. So this is an example of a reversible process. Let's look at our piston system that we're becoming very familiar with at this point. So we have a gas in this piston with a movable disc, the piston, and what we're going to do is compress the gas by adding small weights to the piston so that the surroundings do work on the system. So we'll add those incrementally, small weight here, another small weight, and slowly, incrementally decrease the volume of the system or compress the gas. So when we're doing this, the surroundings are doing work on the system because we're compressing the system. I can imagine just simply reversing that process by stepwise taking a weight off of the piston so that the system does work on the surroundings. When I do this, the amount of work that the system does on the surroundings going in the reverse direction is equal to the amount of work that the surroundings have done on the system going in the forward direction. And thus, each state of this system is a well-defined equilibrium state, so every intermediate state is a well-defined equilibrium state, and so I can reproduce that well-defined equilibrium state and get back to the initial state of the system that I started with. Practically, what defines a reversible process is one that's done so slowly that the system remains in well-defined equilibrium state throughout the entire process. When I do this, I can return the system and the surroundings to the same initial state that they started in, and that is what defines a reversible process. Let's contrast that to a process that is irreversible. So to illustrate this process, I have my gas contained in 1/2 of a big rectangular container, and I've got a little hole that I can open up that will allow the gas to move from 1/2 of the container to the other half of the container. So I'm going to expand the gas, but I'm going to let it expand freely into the empty half of the container. So if you think about doing that, and then you imagine how would I get back to the initial state, you can't imagine just figuring out how to stuff all those gas molecules that have expanded into this half back into the first half and then closing the hole, which is what you would have to do to reverse this process. So this is irreversible. In order to get the gas particles from this part of the box into this part of the box, I'm going to have to use some energy to do that. I'm going to have to pump them out and into here and close off this hole so that they stay in the left half of the box. And when I use that energy, I'm using energy from the surroundings, and that means that even if I get back to this initial state for my system, my surroundings are no longer in the same state because I've had to use energy from the surroundings in order to make that process reverse. So this is an irreversible process.